So this will be the second recording for today. So just looking back at this for a second. So this is a set piece. Remember that we divide our course up into content and skills. And the content is like the equations and the conceptual things that you deal with. And the skills are kind of like things that you can do with it, or things that I can ask you about. So I can do, plug and chug, where I just give you a whole bunch of, I give you sentences, and then you draw a diagram, and you pick an equation, and you plug numbers in, and you get a numerical answer. That's traditional. But then there's also conceptual. That's a skill. Can you answer conceptual questions? And then there's also those graphical questions. Can you get the trace from it? And then this is one where I call them ratio questions, where you basically, you're given the original value, and then you change the parameters in certain ratios. Then can you find the new parameter? And as I say, the most common for people who know what they're doing, what the most common mistake is if they're kind of doing the layout, but they just leave this bit off, where they just forget the beginning bit. Then most common mistake is they only give me the ratio value, and they'll say 12 newtons rather than multiplying that ratio by the original value, which will be 72. And it's just a shame to lose points that just because you're not writing down the full sentence. Try to think of writing down these ideas as full sentences. An equation is a full sentence. It's got a beginning, a middle, and an end. Whereas a statement like that would be a phrase. It doesn't equal anything. It's a thing in itself. So try and write in complete sentences, and try and think of it as a language, and it will actually get steadily just easier and easier, I think. Let's go on to this next bit, which is doing statics with friction. So we say a horizontal applied force causes a 2 kilogram block to slide at a steady speed. So visualize. This is going to be a 2 kilogram, and we have a horizontal FA equals 8 newtons, and steady speed, so V is equal to 7 meters per second. It's going in that direction, same direction as the force. What is the coefficient of kinetic friction between the block and the table? So I want my mu k. So okay, we're on our way. Let's talk about it, and then I'm going to cut you loose on it. You need to complete your diagram. You need to find an expression that has mu k in it. You need to find out what you need to find out and solve it. Okay? So I'm gonna turn this on, because I want you to, I'll talk you through it, but you need to work through that. So we're back, and let's just put a pause on this. And let's see what most people are saying. So most people are saying C is the answer. Let's just check that out. So skill number one, getting from the words visualization. So skill number one is getting the diagram. And then you got to recognize some things. And we had to recognize that a constant or a steady 7 meters per second told us that our acceleration was equal to 0. And that told us we were in equilibrium horizontally. We know we're in equilibrium vertically. And so we're looking for an equation that has mu k in it. And we say FF is equal to mu k times Fn. And we say, okay, well, mu k is equal to FF over Fn. But then you say, but I don't know FF. And I don't know Fn. So now I divide up my paper a bit. And I'll do it in 2 bits. And I say, well, find FF using FF is a horizontal bit. So I'm going to say using the sum of the forces horizontally equals 0. But it's moving horizontal. Yeah, but it's not accelerating horizontally. That's the key thing. That's the big thing that catches people. They associate equilibrium with stationary rather than not accelerating. And they're just not quite the same. So then I say, well, let's have a look at this then. I'm going to say plus 8, looking at my diagram, plus minus FF is equal to 0. So FF is equal to 8 newtons. Not so bad. And then I say find, let's spell find right. Find Fn using, and it's not accelerating vertically either. So it's the sum of the forces is equal to 0 vertically. And I say plus Fn added to minus 20, because it's pointing in the opposite direction, equals 0. So Fn is equal to 20 newtons. So then I turn around and say, oh, okay, in that case then, bring those two back up here. FF is equal to 8, and Fn is equal to 20. So that's going to equal 0.4 and no units. Put it in a box so I know it's my answer. There it is. So a whole bunch of skills there. Going from the words to the diagram, critical skill, and then going from the question to an equation, that's a first step. But then recognizing this is actually a 3-step problem. You know, you don't know what FF is, so you've got to use equilibrium to find FF, and you don't know what Fn is, but you've got to use equilibrium to find Fn. Yeah.
I have a question. In regards to saying that the block is moving in a steady speed, that means FA is equal your FF.
That's what I just said, yeah. FA, that's FA. That's your FA, and it equals your FF. Yep. FA, FF. So you could just observe that.
Well, that's what I'm saying. We don't need.
But we will.
Just doing the diagram.
You know, we're not going to stay at that for very long. This is like first steps, okay? And when you start getting slopes, then you can't just do it by observation. Okay, so I don't want you to get into the habit of, oh, you just observe it. You know, the answer's obviously 8, and it's obviously 20. I want to kind of give you a framework, because we're going to do that same framework again. Well, I say we. So, 3 kilogram block is stationary, but on the point of slipping. So I changed it a bit, but it's still equilibrium. What is the coefficient of static friction of the block on the incline? So it's 20 degrees. Again, be careful that you draw a good diagram. 20 is not 45 degrees. You want big angles and small angles. This is going to be 30 newtons, and that's going to be 20. And there's, what is this force? Yeah, it's perpendicular to the surface. It's not vertical. Fn can be wherever the surface points. And which is the way that the block would like to slide?
Down.
So that means that FF is going to be FF. And what do I want to find? Mu K. So in a way it's the same layout, except the 2 bits are more complicated. You're going to find an equation that has mu K in it, and we only know one. And you're going to realize that you need Fn and FF, and then you are going to use your skills of resolving forces to find Fn and FF. So I'm going to pause and let you go at it.
Systems from this same